Hello, my Math 2 scholars. So today we're going to look at quadratic keywords. And this is just basically the start of how we're going to look at quadratic functions. So you should have already watched the video about pumpkin chunking and how that affects what a quadratic looks like. So we have the idea of a catapult that has a pumpkin inside of it that's throwing it. And when that pumpkin throws, it goes up at an angle, goes to a highest point, which is something like this. This would be our highest point, and then it comes back down and it hits the ground. So you should have a paper that says quadratic keywords at the top, and we're going to talk about what each of these things mean. Okay? So first of all, if we looked at the middle of this quadratic function that we have here, then we know that this line that goes down the middle, this line here, would be called our axis of symmetry. So let's write that down. This line right here is called our axis of symmetry. In the past, you may have seen it called a line of symmetry. That's our axis of symmetry, okay? And you'll notice that it goes through the vertex, okay? It goes through the vertex. Now, the standard form for a quadratic function, is going to be y equals ax squared plus bx plus c, where a, b, and c are numbers, okay? So we've got, let me zoom in a little bit here for you guys. So this is the paper we've got. I'm going to zoom in so you can see a little bit better. All right. Let's zoom. Maybe it'll get focused here. All right, there we go. So ax squared plus bx plus c, a, b, and c are going to be numbers. And this shape that we have down here of this graph that goes up to a certain vertex and comes back down, we call that shape a parabola, okay? So you may hear me say the word parabola. Now, if we look at this vertex that we have here, okay, at the vertex, the x value of the vertex is going to be when the object is at its maximum height. So this x represents time, okay? This represents time. So if you need to, write out here time. It's when the object is at its maximum height, okay? The y value is how high does the object get. So the y value will represent height, okay? So your x represents time, your y represents height, okay? The other thing that we'll notice here is the y-intercept. This right here, the y-intercept, okay? Now, your y-intercept is where it crosses the y-axis, okay? Where it crosses the y-axis. Now, in the instance of pumpkin chunking, this would be the height at which that pumpkin is launched from the catapult. So that catapult is going to be sitting so far, so high up off the ground, and when that pumpkin is released, this height right here is the height that that pumpkin was released from, and then it goes up to its vertex, which is its maximum height, okay? Now, that y-intercept, if you'll highlight right here, tells you how high off the ground that object started, okay? That's what that y-intercept tells you. So these two things here are connected, okay? So the y-intercept tells you how high off the ground that the object started. Now, if we have any of our x's that we want to find, okay? If we have any of them. So like how high is the object after, let's say, x seconds, okay? After 2 seconds, after 3 seconds. Then what we would do is we would plug that given x in. So plug the given x that's in second into the graph's equation. So in other words, if I went up here to the y equals ax squared plus bx plus c, For every X that I see, I would plug in, say, if it's 2 seconds or 3 seconds to come up with how high the object is, okay? So you can plug in any value of X and come up with a Y. Now, the other thing that is super important with these quadratic keywords are these words down here. This word here, 0. Okay? Now we have 4 different words that are going to mean the same thing. And I'm going to teach you all 4 of those words today. And hopefully you're going to remember those words. Okay? So those words are 0, also x-intercept. You can see that it's where it crosses the x-axis. Okay? So it's where it crosses the x-axis. You could also call them solutions, and they could also be called roots. So we have 4 words that mean the same thing. All of those are connected. If you are asked for zeros, roots, solutions, or x-intercepts, all of those words mean the same thing. So you're looking for where it crosses the x-axis. Now, this positive 0 over here is important. This one right here. This positive 0. Now remember, we're talking about a pumpkin that's being launched from a catapult. So if this is my launching point, this is the highest that it gets, and then it's coming back down. Eventually, when it comes back down, it's going to do what? It's going to hit the ground. So this point right here is when the pumpkin hits the ground. So you're going to be able to tell how long that pumpkin is in the air by this point right here. So you might have started at 0 seconds over here when it's launched, but after it's launched and it goes to a maximum height and it comes back down, this point over here might be 3 seconds later. And that would be your X value, because remember, X represents time, Y represents height, okay? So what I want you to realize is that when does the object hit the ground? That's this one. And how long has the object been in the air? So how long has the object been in the air? That's going to be the X value, okay? How long has the object been in the air? When does the object hit the ground, okay? That's what we're looking at. Now, if we look over here at this 0, okay, if we look at this one, this 0, notice what it says. If I don't even launch my pumpkin until here, and this is before that, then this 0 doesn't make any sense. It gets thrown out because it's too negative, okay? We say that 0 is too negative in the case of throwing a pumpkin, or could be launching a rocket, could be anything like that, could be throwing a ball. So anything that happens prior to that ball being thrown or the pumpkin being launched, then this 0 over here is not going to count because it's too negative. All right? Okay, so keywords for quadratics. If you have questions, let me know.